All right, so example 6 says to evaluate. So I want to know what log base, for A, I want to know what log base 3 of 81 is equal to. Well, remember, if it's in log form, we say it's log base B of X is equal to Y, right? So I'm trying to solve for Y. But I don't know what log base 3 of 81 is. I'm not going to use my calculator. So I got to find another way to solve it. But remember, if we're stuck in log form, log is we can switch it to what kind of form? The exponential, because remember that b to the y will equal x. So if you're stuck in one form and you're trying to solve, just go to the other one. So that's what I'm going to do here. So what is my b? So log base b of x. What's in the place of x? 81. And what's in the place of y? Good. So when I set it up into exponential, I get b to the y equals x. Can I get like bases here? Because remember, if I can get my bases to be the same, then that means my exponents have to be equal. Well, is 81 3 to the anything? Of course it is, or I wouldn't have asked. So, well, yeah, let's break it down. 81 is what? 9 times 9? And each 9 is 3 times 3, isn't it? So how many 3's do I have there? So 81 is the same as 3 to the 4th. And that's going to be equal to 3 to the y. And once you get your bases equal, you can ignore them. Because if your bases are equal, then that means your exponents have to be equal as well. So y is going to be equal to 4. So let's try b. So it's in log form, so I'm going to set it equal to y. And I'm going to list out my pieces. So what is my base? What is b? 49. Log base b of x. What is x? And what is y? So I'm going to set it up into exponential form. So my b to the y equals x. All right, so 49 is my bigger number, the bigger base. So can I make 49 into a base of 7, the smaller one? Yeah, 49 is 7 to the what? Squared. But then we still have that y on the outside, so it equals 7. So what can I do right here in the exponents? That's what we call power to the power. What do we do with those powers? You remember? No, that's when we're multiplying with like bases, we add them. We're going to multiply these powers, okay? So when I do that, I'm going to write it over here. That's going to give me 7 to the 2y equals 7. What's the exponent on that 7 I just wrote, the last one? 1. A 1. Because now my bases are equal, aren't they? So I don't have to worry about them. And so I know the exponents have to be equal. So 2y equals 1. Solve for y. No, 2y equals 1. So what is y? 1/2. And remember, 1/2 is the same as the square root, right? So is the square root of 49 equal to 7? Yeah. So we did it right. All right, what about c? It's in log form, so let's set it equal to y. So what's our base? What's our x? And what's our y? All right, so I'm going to set it up in exponential form. So b to the y equals x. Oh, we don't like fractions, do we? So I need to pull this 8 up to the top. What can I do to make it go up to the top? Do you remember? Change the sign of the exponent. So this means that 1 over 8 is the same as 8 to the negative 1. Remember before when we were plugging in, we had 2 to the negative 1 and we said that was 1/2 because the negative exponent made me send it to the bottom. Well, if it's on bottom and I want to bring it up, all I do is change the sign of the exponent as well. So it was 8 to the first on bottom, so I brought it up, made it 8 to the negative 1. And so that's equal to my 2 to the y. So my bigger base is 8. Can I take that 8 down to a base of 2? Yes, 8 is 2 to the what? Third, and I still have to the negative 1 there. So 2 to the y equals 2 to the, what do I do with these exponents? Multiply them. And so we get, whoops, helps if I can multiply, yeah, negative 3, right? Say it again. I would not put that back into a fraction. Why? I don't want a fraction. My bases are equal though, aren't they? So we can ignore those bases because we know our exponents have to be equal. So y is equal to negative 3. There's nothing to solve, so there's my answer. All right, D. It's in log form, so let's set it equal to y. I know it's a little redundant here, guys, but they're coming up with some different things, so we're going to have to work some things out. Or different ways, so I'm going to go through them all to remind you of stuff. All right, so on D, what is my base? What is my x? And what is my y? So b to the y equals x. Well, 1,000 is the bigger base. Can I take that down to a base of 10? Yes, so 10 to the y equals 10 to the, count the number of zeros. 3. The number of zeros always tells you the exponent, 10 to the whatever, okay? And so my bases are now equal, so ignore them. And we know y is equal to, good, 3. So y'all know that means that log base 10 of 1,000 is equal to 3. All right. Just making sure there. All right, E. It's in log form. I'm going to set it equal to y. What is my base? What is my x? And what is my y? So b to the y equals x. Yeah, that second 7 there has a 1 as the exponent. Base is already equal, so y equals 1. All right. Let's see for the next one there. It's in log form, so I'm going to set it equal to y. So what is my base? What is my x? Good, 12 to the 143. All of that right there is our x, okay? Equals y, which is set it up exponential. So b to the y equals your x. Very good. So y is equal to 143. All right, I'm going to come over here to the side. You can work it down below. I just don't want to scroll down just for one problem. So G. G says log base 4 of 1. And so it's in log form, so we know we're going to set it equal to y. What is my base? What is my x? And what is my y? So b to the y equals x. Well, 4 is my bigger base, so can I take it down to a base of 1? I can't. Oh no. Alright, I can't, but this has a special rule. Remember, there's something that we can raise anything to, and our answer will always be 1. 0. So this is one of those you're just going to have to recognize, guys, that exponent has to be 0.